Ishida about the role of Fink in alerting everyone with what's happening from Rubin. Thank you.
Hello. Okay. Perfect. Good morning, everyone. Thanks a lot for having me here. Thanks for the organizers. Just some caveats. I am going to talk to you about Fink and the European Broker Initiative that we have within ACME. I have to excuse myself. I was not supposed to be here. I'm substituting Julien because Julien is the main developer of Fink, and he is the one who is like really, really hands-on on the technical part of the project. I mostly do scientific coordination. I will do my best to answer your questions and go forward as the best that I can, but I can also redirect you to Julien in case I cannot answer your questions. So I have just to set up the stage here, we have been talking a lot about brokers and LSST. Just to remind us a little bit more, once more, what is the goal of a broker? So something happens on the sky, the telescopes detects it. Every time there is a signal in a difference imaging analysis that is higher than something around 5 sigma, this produces an alert. This alert is sent to a broker, and the goal or the task of the broker is to use whatever is necessary. Machine learning, catalog classification, stream join, people looking at it, whatever is necessary to separate this data and lower the burden of the stream and send to the users only the small pieces of data that are actually used to them. The catch here is that these people would only like the interesting ones. So with ZTF, we are working with ZTF right now. We receive around between 200 and 300,000 alerts per night. With LSST, the expectation is that it's going to be 10 million alerts per night. These people do not want more than 5 or 10 per night. And if these people, and they probably want different things. So if this guy is studying galaxies and the other guy is studying exoplanets, they want completely different things from the data, and the broker needs to be flexible enough in order to allow that personalization to happen. So I'm going to talk to you first about Fink, and afterwards a little bit more about the broad scope of things. So what is the point of Fink in a nutshell? So I think the main thing that you have to remember about Fink is that it's a relatively new project. So Fink has 5 or 6 years right now. Like we started in 2019, which means that 5 years ago, I had no idea what an alert was, which is like a very different situation of what we have right now. And Fink is mostly community-based, community-driven, meaning when you go to your website and you look for something or you use the API, every single thing you see is because someone asked for it. So if there is something that you think we should do and we don't do it, it's probably because nobody asked for it yet. We go where the pressure is higher. So please talk to us. It's a project that started in France in 2019. Nowadays, we have around 70 collaborators from 15 different countries that are working on around, I don't know, around 15 science modules, more or less. It operates 24/7, so we have the infrastructure for now, which is processing ZTF data in Paris-Saclay in virtual data. For LSST, the processing will be done on CCI and 2P3. But the virtual data at Paris-Saclay will continue to operating with ZTF data. So we will have 2 parallel things for doing that. And so these images were supposed to show you the 2 telescopes that we work on, which is Rubin and ZTF. And from of the website, we have a new website that was out today. So if you are curious, you can take a look at that too. As I told you, it's community driven in the sense, what happens here is that the Fink team, what we normally say is that processing is centralized, development is distributed. Meaning, we have the infrastructure of Fink and the core team that is that is responsible for developing the main infrastructure. And then we have science modules. So we have different groups working in different science cases. Each group is responsible for managing their own activities. So they produce their code. We help. We help. So we interact with them a lot to make sure that the code they are developing in the science case they are trying to achieve is compatible with the infrastructure that we have. But mostly the science teams are responsible for developing their own infrastructure. In this sense, we have satellites, solar system, galactic science, microlensing, cataclysmic variables, YSOs, blah, blah, blah. A lot of extragalactic things, supernova, gamma ray bursts, clinova, and also some not so well-defined cases like anomaly detection or hostless transients, which is a specific request that was done and developed by users which were interested in the specific characteristics of the data. This plot here is just, we have in the website, there is a link to the statistics. So if you wonder why you didn't receive alerts in a given night, you can come here and you have one little block for each day of the year, and it will tell you how much data we received from ZTF at that particular point. So the largest, strongest orange ones is around 300,000 alerts per night, more or less. What have we done so far? So we received around 280 million alerts already. A typical night, as I said, is between 200 to 300,000 alerts, and they are more or less separated like this. So you have mostly variable stars, a lot of variable stars, solar system objects, candidates, and then some core collapse and some different anomalies. The anomaly specifically depend on what you consider an anomaly, and it's the user that puts the threshold. So we decided, and it was a completely executive decision without, I don't have a good reason for it, but we decided that we would identify 10 anomalies per night, meaning we have an anomaly detection model that each night identifies the 10 alerts most weird, let's say, in question of anomaly score, and the 10 most anomalous alerts from each night are categorized as alerts and get a tag for it. But you want to talk about gravitational waves. So what can we do about gravitational waves? Okay, so there are two things that you can do. So if you go to the website, you can cross-match every alert that we received from ZTF with a given GCN. So this is already on the web page, and you can you can already do it. The problem is that sometimes these areas, depending on probability threshold that you put in, is super big. So you're going to have like a million alerts, which I'm not sure if it's super useful, but it's there. And if you have something, you can definitely match. So here you have a histogram of more or less, and there also an API with a by-star endpoint that you can do it. This thing is done by this type of alerts, but it's completely customizable. So if you have any other type of sky maps that you want to cross-match, it's also possible to do. You just have to talk to us. So what I said before, it's something that is available on the website, and you can do it just going there and clicking and things like that. But that is not online, right? Like this is after the fact. So you go there and you cross-match with alerts that are in the database. For real-time processing, we have Fink, which is a real-time cross-match between what ZTF receives and some other sources. So this is this was part of the PhD thesis of Romain. He defended last year. And then everything here is scalable and customizable, and this would allow you. So if you have a probability map, you could receive the things online in the middle of the night as we process the alerts. So just something for you to have an idea. So these are mainly from Fermi, but the error bars are huge. And as you can see, from nightly, you have like 80,000 alerts that cross-match with some given alert. And then when you look at those things and you think, oh, what I am cross-matching with, you see that most of the things are solar system objects. These we can identify because we cross-match with the minor planet catalog, so we can remove or follow this up. And the most things are the unknowns. There's a lot of unknowns and some other objects. What to do with the unknowns is up to the user. We can obviously develop more filters and more being more specific about your specific science case if you have the requirements that you want. Yes. I don't know. Sorry. There's probably an explanation there. Not my slides. I'm sorry. Yeah. Okay. So we have been in a few years ago, we had a very nice partnership with Grandma also that Sarah is going to talk to you about in a bit. These was developed within Fink 3 different modules for trying to identify kilonova candidates. One of them was based on machine learning, one of them was based on rate-based classification, and another one considering contextual information. It has produced some interesting results in collaboration with the Grandma team. This needs to be updated up to this point, but it was a very successful collaboration that we can showing that this is also possible to do. Okay, so what do I have to tell you about this? So as I told you, Fink has a centralized processing and decentralized science. The users are the ones who actually extend and give new capabilities to Fink. The science modules are developed by individual groups. Each group is responsible for defining their own publication policy. The only thing that we ask is that they cite Fink and that they put in the acknowledgements this was done using Fink. Anything else, if they want, but there is no publication policy or anything like that. This is the only thing that we ask for them. Caveat, the data for ZTF and also for LSST, the alert data will be completely public from start. So their releases are different, but the alert data is completely public from start. If you develop a science module for Fink, by definition, the output of your module is public for everyone. So everyone has the right to use the output of your module, even if they don't contribute to the development itself. This is good because it allows new users to take advantage of all of the things that were already developed in the past. So for example, if you come with a new science module today and you want to use the anomaly scores or the features that were developed by some other team, you are free to use it. So this is a huge thing, which we mean by one man's trash is another man's treasure. That sometimes you do something because you want to filter out something, and there was another person that want to look at that. I had a recent paper that we were identifying artifacts, and we managed to say that asteroids were artifacts because we are all extragalactic people, which was not a good thing. It was not a Fink paper, but it's something that I learned from Fink that we should try to be very, very careful. Okay, so, but apart from all this, and this is connected to what I have to tell you now, that there is a huge philosophical part on this, which is we consider brokers to be discovery machines, because whatever is happening on the sky on real time, if you want to know about it before everybody else, you will have to go through a broker in the context of LSST to be able to know about it. And we also believe that it is very, very important that to have the development team of engineers that is developing the infrastructure talking with the user who has zero knowledge of machine learning or high performance computer or whatever from the beginning of the development of the pipeline, because this will save you a huge time in the development process and make sure that you are actually going to develop something that's super useful. we are trying to push these. We are pushing this forward for LSST. So as I told you, you probably know, first light is supposed to be in summer, in July 2025. If I remember correctly, the first alerts are supposed to arrive to us around September or something like this. Be aware that the first year of LSST, alerts will not necessarily make sense, because in order for alerts to make sense, you need decent templates. And it takes it will take some time to get decent templates for difference imaging analysis to make sense. We are almost done with the migration to CCA and to P3. For people in France who have access to the LSST data rights, you will also be able to cross-match, you will also be able to use that information with catalog data of LSST. And then there was on some operations rehearsal some time ago. We were super happy with the performance of the broker, with the caveat that obviously this is simulated data and we have no idea what is going to happen when real data start flooding. But anyway, we were happy that things broke as we expect them to break. Let's put it like this. Yes, I talked to you a lot about Fink, but obviously we have to also talk about the big picture. We are talking about ACME here. So Fink is one of the LSST brokers. So in 2001, LSST made a call, an international call for broker teams. 7 brokers were chosen to receive the raw alert stream from LSST. So these are the seven. So there are 3 in the US, 1 in Chile, and 3 in Europe, which are going to receive the raw alert stream, and it is the task of these brokers to redirect this stream to the community. So meaning that in this scheme that I told you before, we are going to have more than one broker that will give that will have this task of sending things to the users. In Europe, we have Fink, we have Ample that you already heard, we heard here this week, and Laser in Ample in Germany and Laser in the UK. The 3 European brokers, and I was very, very impressed with ourselves when I was preparing this talk, because it's since 2021 when I came back to my notes. I didn't expect it to be that long. But since the beginning, basically, we have been trying to talk to avoid doing 3 times the same thing arm's length away, right? So it is very nice, because the broker community, I'm not sure if it's something that LSST predicted would happen in the beginning, but it did. And we are trying to build a culture between the brokers, which is very collaborative. And this is basically what we are trying to do. So I went back through our notes. We had a letter of intentions that was written in 2021. And the points that was like developing standards and protocols for combining data from different experiments, cross-match with existing catalogs, framework for sharing input data for machine learning applications, because a lot of the brokers have some machine learning component of it, and implementation of an European repository for Rubin alert information. There is the 3 brokers are going to receive alert, which means that it is 3 times the same data that is being sent to Europe, and we would like to have an idea of how to store and use this properly without repeating the effort. So all of this happens, and this didn't have a name. But then with ACME, we became the Euro Broker Initiative, because then we had a name and we are in one of the work packages. And the idea is to focus on technical and complementary challenges of this. So, when the ACME project was found, included in one of the work packages was some contributions for your every broker teams. So we had some human power that was allocated for each one of the brokers. The idea was to make the broker as a whole, all of the brokers, to be easily accessible by the community, depending on your flavor of what you want with each one of them. A few of the questions that we thought we would talk about, we would address, was something like, do we need a central database? The alert, I didn't talk too much about this, but the alert package includes information about photometry of that specific point on the sky, but also 3 image stamps. So these are small cutouts with the transient on the center. We get the science stamp, which is the one of the observation, the template one, and the difference imaging one. This is by far the largest part of the alert in about the volume of data, right? And we are storing this 3 times. So we would like to have a better way to deal with this. Talking about Kafka streams and how they operate and how they can communicate better, sharing operation logs, allowing data flow and interoperability between the brokers. So these are a few of the things that we have been discussing in our meetings. I'm almost finishing, so I wanted to tell you that there are small details that matter. We have 2 brokers with web interfaces, and I'm super happy to see that the Lazare interface has a Fink connection, and the Fink interface has a Lazare connection with it too. I always tell people that not knowing that other brokers exist is not a valid reason for using Fink. So go there, look at they're doing amazing stuff. Maybe if that fits better and it's easier for your science case, please go there, and we'll be more than happy to direct you to the correct tools. I talked a lot. There are real difficulties of this, and most of the difficulties, let's put it like this. I think technological difficulties we can overcome, because sociological difficulties are a little bit more complicated. So we are facing a lot of sociological problems, especially because the interface between high performance computing and big databases facilities and the user is very different, and it changes very fast. And that adaptation for the community needs to be eased from both ways, even from the developer side and for the user side. And there are some pressing questions that all teams have to deal with. So for example, how to make sure that the tools fit the user skills. It's much more like, do we want to get science out of this? I cannot wait for the entire community to learn a completely different language until we get, this is not going to happen. It's better to talk to them and understand if we have a middle ground where we can communicate with the user. How to make sure that the tools are used efficiently, and you are not going to, because for example, we had to develop in Fink a data transfer service where you can go there and download book a lot of type of data, because people were using the API with a loop, with a waiting time between each loop, so they can download the entire Fink data set, and this was broken the system. So this type of thing we also have to think about, and how to make tools flexible enough to be adapted, because remember that adaptation is a very important thing. Each user community wants a different thing, and the broker should be able to adapt to those things. So I am done. I just want to, if you have to forget everything I said today, I just want you to remember that this is an intrinsically sociological development that requires a lot of talking. So Fink has been from the beginning hosting different meetings around the globe. We have nowadays organized efforts in Australia and Brazil using Fink data, and we always try to make this like not so big meetings, so we can really bring the developers to talk to the users and try to make sure that this conversation between the two communities are happening. So whatever technologies we are going to develop in the future, we'll have to go through that type of dialogue, I'm sure. I'm happy to take questions. Thank you very much.
Thank you. And questions now, the audience or online?
I wonder if you plan for preparing LSST some like dry run or some dry run with follow-up team or something like this, right, to get ready for July or September or whatever it is.
Yes. The question is yes. So the answer is yes. So we had planned, because there are some alerts that are simulated. For example, we were planning to do this with OR5, which was the operation rehearsals. The problem is that we did not find a suitable simulated data set that would allow us to test all of the things that we want to test. Because, for example, in the last, there was some simulation issues in the last operations rehearsal that made not all of the data pass through the models that we have. So the answer to your question is yes. We are going to have some like online hackathons to help people deal with the data. I cannot promise you when now. It's definitely going to be before June. But I don't want to make strong promises about dates. But yes, that's going to happen.
Further questions? Yeah.
So this is really just a curiosity. Can you say a bit more about these sociological problems, what it is about the evolution of the HPC systems and so on that's causing you so many problems? What is sort of happening? You know, you said there's these problems because the computer landscape is changing and they're sociological. Can you elaborate a bit on what some of those are? I'm just curious, really.
Yeah, so so it depends a lot on the user community that you are working with. Most of the users that we have, they do develop, for example, codes in Python and things like that. They are used to that. But Fink is based on Spark. So if you want your code to work with the Fink interface, you have to code for distributed computing, which is different. So our experience is that we have been having this two-way conversations with different teams in order to help them understand how to adapt the infrastructure that they have to something that would work on the broker. But this is like a one by one. You see, like, it's a very, very slow process.
So it's literally users are building their own tools that they want to embed in the broker to work on their laptop, and then it just doesn't work when you...
No. Fink, it's different from Apple. Fink does not work locally. No. So you develop your tool. So what you do is you can go to the website and download books of data. And then you develop your tool in your computer and it works. So once you are happy with your module, then you have to talk to us. And we are going to work with you to upload your code to the broker and run there.
Yeah, so what I mean is that people are doing that in the mindset of, oh, I'm making it run on my laptop, but then it doesn't work when it gets you, and that's the problem, right?
Yes.
So do you have like templates of how to, you know, here is some template, right, and people just ignore them?
Yes, yes. So we have, no.
Users don't read documentation. Documentation is a write-only process. I'm convinced.
Yeah. So I will not say that they ignore it because they are aware of its existence, even if they don't pay too much attention to it. But we do, so we do have tutorials and examples online. We always point the users to that, but it's also impossible for us to make a tutorial that will address each questions because each science case is different. So these tutorials are more like, try this first, right? So you try this first, and then depending on the problems that you're having or things that you want to do different from what is in the tutorial, then we're going to talk to you and help develop that tool. There's also a problem of computer performance here, because since we provide the computational cost for running all of this, you have to remember that if you want to process 10 million alerts per night, your model cannot be super complicated. Otherwise, you will use 100 million cores per night. So from the user side, it's also difficult to estimate that, because since it's a different system, they cannot completely test it locally. So there's a lot of back and forth. Our experience is that once someone wants to build a science module, we had a back and forth with them for a few months, 4 or 5 months. And after the thing is running, then they already know enough to deal with their own and work with pull requests and things like that.
Do you have like a scratch space on your servers that people can, instead of them developing it locally, you can build your module from scratch on your distributed thing? Is there like a space?
Not at the moment. No. Not at the moment. We do have a few. Like very experienced users that have access to the Spark cluster, and these people serve as like ambassadors for the other science team, and they provide this connection. But we don't have resources actually to have something like that.
So I wanted to first understand, so you mentioned that Fink is being run in, the ZTF Fink version is being run in at Saclay, then the LSST one at LSST, so at CC. So I guess that's because of the data volumes, and you don't have the resources
yes.
Then why don't you move everything? I mean, or how do you actually distribute the two locations? So that I suspect it will feel like one system, or do you have to log into 2 different websites to get the data?
So I am getting into things that are not my piece of cake here. So what I understand is, first of all, in the beginning, we didn't knew there would be overlap. ZTF was extended, right? So in our planning, we would work with ZTF in virtual data to prepare the things, and then once LST started, we would move to CC. So the extension of ZTF made us make different plans. And one thing that we learned with the rehearsals and with Elastic and other things is that going from ZTF to LSST is going to be much more complicated than we had expected. So not only in terms of data format and storage and volume, but all of the machine learning models are going to be extremely different to deal with different cadence and 6 filters and things like that. So it's really going to be two separate systems. It's just like, I understand that this was what we were able to do, given that we were not expecting that ZTF would continue.
So then one more comment. I don't know, I'd like to get your idea. So we will have this hands-on work package 5 meeting in June, and I was wondering whether we should extend it by 1 day and maybe add an extra day for the brokers to sort of sit together in one room and actually work things out.
That would be a very interesting suggestion. That naively I would say yes. I cannot answer for them. We have the next Eurobroker meeting in May, which I can ask them and suggest to them that possibility. Yes, because naively I think it would be nice if the brokers can participate. It would be good. Yeah.
If there are, there was a comment on the chat relating to documentation.
Probably Julien is there. Yeah.
Julien, you can talk if you like.
Oh, well, just to say hello, thanks. Now I put a link to the documentation. Just comment to Marek. Unfortunately, for the WP5 face-to-face, it's exactly the same date as LSST France meeting that we are organizing with Fink. But yeah, we can talk later on this.
Julien, do you want to comment about the ZTF LSST going to being 2 different places?
Yeah, you said things correctly. I think maybe one extra comment is the 2 systems, even though they are in 2 different places, one at University Paris-Saclay and the other one in Lyon, they are connected. There are 2 clouds, and actually from the point of view of the data management, it's the same network. So eventually data will sit at the same place, and user will transparently access ZTF or LSST data. Now, in terms of interface, whether there will be one unified interface or 2 different for ZTF or Rubin, that's we don't know yet.
So, hi, I have a question for you or for Juliana, or if you know the answer, because I don't know if you know, but I try. So, did you estimate, or some other the brokers, I don't know, did? So you receive millions of alerts per night by LSST. Of course, some of them are very easy to classify, maybe. Some are bugs, some are known object, and so on. So I would like to know if you have an idea of the number of alert per night that would come to not new kind of transient, but new object to be classified, like candidate supernovae, candidate transient event, something that is not known already as a variable star, or new object in the sky. So new transient in the sky that you can't put a name on, linked to a specific phenomenon, like asteroids, planets, or star that rebrighten, and so on.
So the question is if we have an estimate of how many new things we are gonna receive. I don't have a number. Julien, do you have a number?
Yes, based on ZTF, and again, I mean, extrapolation to LSST is not obvious, but based on ZTF, that was a few percent per night. So you had 200,000 alerts every night on average, and 1-ish% is purely new transient, something that had no history before. Most of them, we never had a subsequent alert. So that was just like a single alert. So maybe an artifact, but yes, a few percent, 2%.
Yeah, just a reminder that LSST is going to be much deeper. So yeah, so I would naively expect that to be that percentage to be bigger, just because we are going to be probing a different region of the parameter space, because you're going to go deeper. I'm also not super hopeful that we are going to know anything about these things, because you need a much bigger telescope to have a spectra or something more informative about those objects. So there's going to be a lot of very faint things that I'm not sure how much we will be able to talk about.
I really agree, and that's the reason of my questions. I was putting it more in to understand what to do for some follow-up.
Okay. In that case, if there are no further questions, we have a coffee break now, and we will pick up with a few more talks at 25 to 12.